So this is the new example we have for any scalar p. Prove that x square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube is this result. Now in this case, one column is visible as sum of two. So that means we should split this in two parts. What we do here first, x, y, z, x square, y square, z square, 1, 1, 1 plus. Then it come out to be x, y, z, x square, y square, z square, px cube, py cube, pz cube. We'll write this way. First, split this in two parts. Now, when you split this in two parts, this part I'll keep same. X square 1, y square 1, z square 1 plus. In this part, p will be common. And one more thing, x will be common from here, y will be common from here, z will be common from here. Common will be taken column wise or the row wise. So here we'll say first row x common, second row y common, third row z common, and third column we will take p. Then left is 1 x square, 1 y square, 1 z square. Is this okay? X gone from here, so 1 x and x square, and p is also gone. 1 y square, 1 z square. After this, first part still remains same, and what we try now, this and this result we'll try to create same by simply interchanging their places. Because x square y square z square is visible here. Here it is x square y square z square. So what we do here, I just first interchange these two. When we interchange these two, it will come pxyz. Then it will come out to be 1, 1, 1. Minus will come here. Then it will be coming x square, y square, z square, x, y, and z. Okay, one more change. This and this can interchange now because I want x, y, z will be at first place, 1, 1, 1 at this place. If you want that, or you change this, that is one in the same thing. So here now we are taking third step. This step was when we have interchanged one row. Now we are changing the second one. What that is? Sorry, column it was. Now we want change of these two. Column 1 and column 3 interchange. So when you do this, minus pxyz, what this will come? xyz, x square, y square, z square, 1, 1, and 1. And now this determinant will be common in both. And if it is common in both, left is this common, then left is 1 minus pxyz. And now you know how to solve it. By creating two zeros, you can solve this result easily. So I just solve it further. So if you want to solve it further, what we do in this case, first we will take R2 minus R1. When you do this, it will be x square 1, then it will come y minus x, y square minus x square, and 0. And this is z square and 1. And this is 1 minus pxyz. Okay. Now further, one more 0 we will create. So it will be on R3 minus R1. When you do this, it will be 1 minus pxyz. And then it will be x square 1, y minus x, y square minus x square 0, z minus x, z square minus x square and 0. Now we'll solve it further. 1 minus pxyz, and then this time we expand with respect to column 3. Expand with respect to C3. So 1 into its cofactor, this element will be what? 1, 3, 4. So it will be a plus number. So what I should say, 1 into its cofactor. So 1 into its cofactor. One more thing, before that, one more thing you can do. Before expanding, it's better you take y minus x common from here and z minus x you take common from here. So one more step you take. So that will simplify your result more. This will be 1, y plus x, 0, 1, z plus x and 0. And now you expand. Expand with respect to column 3. So when you do it, 1 minus pxyz, then y minus x, z minus x, 1 into its cofactor. What it will come? 1 y plus x, 1 z plus x. Now when you solve it, what this result comes? 1 minus pxyz, y minus x, z minus x, and then z plus x minus y minus x and x cancel out. Left is what? Y minus x, z minus x, z minus y, 1 minus pxyz. And now further we solve. I told you cyclic order must be there. So when you go for cyclic order, 1 minus here, so x minus y, 1 minus here, y minus z, z minus x, so plus will come because 1 minus 1 minus, 1 minus pxyz. In this question, they can ask one more thing. If x is not equal to y, y is not equal to z, z is not equal to x, then question is find what is p. Can you do it now? What is the change? And in this case, one more thing they will give. The whole expression is equal to 0. That means they give this way. X square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube equal to 0. This is a new question. Then find out p if this condition holds. Then first thing, when we have solved this part, I got this result, and then this result has to be 0. This cannot be 0 because x is not y. This cannot be 0 because this is condition given. This is also condition given. So left is 1 plus 1 minus pxyz equal to 0. So what is p now? P will be 1 by xyz. This way you can give the second part of it. If they ask one more question you have in your NCERT like this, so that you can complete. Next question, write down please. Next question says a square plus 2a square plus 2a, 2a plus 1 and then 1, 2a plus 1, a plus 2, 1, 3, 3, 1. Question is, prove this is equal to a minus 1 whole cube. This is the question we have. So again we have 3, 1. So 2, 0 you can create. I go for R2 minus R1 first. Then I'll write it a square plus 2a, 2a plus 1 and then 1. Then what it will come? 2a plus 1 minus a square minus of 2. This will come 2a, a plus 2 minus 2a minus 1. This is 0. Then this is 3, 3 and 1. Now when you solve it further, what will come? Just check. A square plus 2a, 2a plus 1, this is 1. Then what this will come? 2a and 2a cancel out. Left is 1 minus a square. Here it will be coming 1 minus a and it is 0. This is 3, 3 and 1. Now we write third case. R3 minus R1. So it will come out to be a square plus 2a, 2a plus 1, 1. 1 minus a will be taken common from here. That is a easier way. So 1 plus a left. This is 1. This is 0. Then left is 3 minus a square minus 2a. Then it is 3 minus 2a minus 1. And then it is 0. Now when you solve it further, what will come? Just check here. 1 minus a square, a only. Then comes a square plus 2a, 2a plus 1, this is 1, 1 plus a, 1, 0. Then minus I'll take common, a square plus 2a minus 3 will come. Here it will come 1 minus 2a. 2 minus 2a, sorry. So 2 will be common and this is 0. Now, can you split this in two parts? A square plus 2a, 2a plus 1, 1, 1 plus a, 1 and 0, minus this will be a square plus 3a minus a, minus 3. And this is 2 times 1 minus a and 0. Now when you solve it further, what change will be here? This is going to change. Minus is here. What will be factors here? A plus 3 into a minus 1, 2 times 1 minus a and 0. And when you go for it, 1 minus a further will take common. Left is a square plus 2a, 2a plus 1, then 1, 1 plus a, 1 and 1. Left is minus of, minus will be plus now, a plus 3, 2 and 0. And now you can open it. 1 minus a whole square is here. Then 1 into its cofactor, what it will come? It will be 1 plus a, 1, a plus 3, 2. Now you solve it. Now what it will come? 1 minus a whole square. This will come 2 plus 2a minus a minus 3. So 1 minus a whole square into, what this will come? Minus 1 and plus of a. So it is coming a minus 1. So 1 minus a whole square into a minus 1. This also I can write as a minus 1 whole square and a minus 1. So it will be a minus 1 whole cube. This will be the answer we have in this question. And in the next class or next videos, 2 videos I'll take, and I'll take some difficult problems in the determinant, and we'll try to finish out this chapter. And then we'll go for next chapter. Thank you.